Hi everyone, welcome to week 13 of our SHSAT training program. This week's math topic is the coordinate plane. So this week I'm going to tell you guys a little bit about the coordinate plane and the properties and different rules for solving different types of problems on the coordinate plane. So first we need to learn what is the coordinate plane. And so it's basically a grid that lets you denote any point in 2D space by telling you the horizontal component of the point and the vertical component of the point. So the horizontal component is how far away it is horizontally from a central point, and the vertical component is how far away it is vertically. So, if we look at our diagram here, this point right here has coordinates 3, 4 because it's 3 to the right of the center of the vertical center, and it's 4 above the horizontal center. So that's why that point has 3, 4 as its coordinates. You can tell it's 4 above the x-axis and 3 to the right of the y-axis. So also the horizontal coordinate is known as the x-coordinate, and the vertical coordinate is known as the y-coordinate. So in the case of 3, 4, the x-coordinate would be 3, and the y-coordinate would be 4. And the origin is sort of the central point of the coordinate plane, although that doesn't really make sense because it's infinite in all directions. This is the point where the x-axis meets the y-axis. This is the point that all your other points are basically referenced from. So any other point is okay, it's this far to the right of the origin and this far above the origin. And the coordinates of the origin are 0, 0. Another important thing to note is the coordinate plane splits the 2D space essentially into 4 parts. So those 4 parts are known as quadrants. So if you want, their quadrants have numbers, and the way you number them is you start on the top right and you go counterclockwise. So the top right, where the x and the y coordinates are both positive, is quadrant 1. And quadrant 2 is the one on the top left. In quadrant 2, the x coordinate is negative, but the y coordinate is still positive. Quadrant 3 is the bottom left. There, the x-coordinate and the y-coordinate are both negative. And then quadrant 4 is the bottom right quadrant. There, the x-coordinate is positive, however, the y-coordinate is negative because it's to the right but also below the origin. And we can also find the distance between 2 points in the coordinate plane. So this is known as the distance formula. It's essentially just a restatement of the Pythagorean theorem, if you know what that is, but specifically for coordinates. So to find the distance between 2 coordinates, you subtract their x coordinates and you square that, and then you subtract their y coordinates and you square that. You add those 2 values together and then you take the square root, and that's the distance between 2 points. So for example, we can find how far away the point 3, 4 is from the origin. So the formula, so our 2 points that we want to find the distance between are 3, 4 and 0, 0. So to do that, we would have to take the square root of 3 minus 0 squared plus 4 minus 0 squared. Notice that this is just the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is 5. So this line right here would have length 5, because the point 3, 4 is 5 away from the origin. So that's all you need to know. The other thing to note is that this is specifically the Cartesian coordinate plane. So there are other ways that you can denote points in 2D space. However, they're all much more advanced. You're going to learn them probably later in high school, so they're not going to show up on the test. The only coordinate system you need to know is the Cartesian coordinate system, which is exactly this. It tells you, sort of the horizontal position and the vertical position, and then combining those gives you a unique location in 2D space. So now we're going to look at some example problems. So first we're going to plot these points. So the first point we need to plot is -4, 2. So to do that, remember, -4 is its position, horizontal position, yeah. So we would need to count 4 to the left of the origin, which is right here. So we know that -4, 2 is going to lie somewhere on this horizontal line, and we know it's going to be 2 above the x-axis. So this point right here would be A, because it's 4 to the left of the origin and 2 above the origin. So its coordinates are negative 4, 2. We can do a similar thing with negative 3, negative 1. So first we're going to count 1, 2, 3 to the left of the origin. And now that's point negative 3, 0. We need to go one lower to get negative 3, 1. So that'll be right here. This is B, which has coordinates negative 3, 1. And the last one is going to be C, 6, comma, negative 2. So now we're going to actually have to go to the right because 6 is positive. So it's going to be 1, 2, 3, 4, 5, 6. And then we're going to have to go 2 down because it's negative 2. So this right here would be 0.6, negative 2. So that's sort of how you plot points on the coordinate plane. The systematic approach is you look at the x value, you go that far in, whatever direction you have to. If it's positive, you go to the right. If it's negative, you go to the left. And then that would be the horizontal position. And then you need to find the vertical position by, from wherever you get to, going up or down the amount that the y value tells you. Now we're going to find the length of these segments. So the length of segment AB is the distance between points A and B, right? So it's the distance between negative 4, negative 2, negative 4, 2, and negative 3, negative 1. So we're going to plug in our formula, which is right here. We're going to plug this in, except we know what x1, x2, y1, and y2 are now. So the distance between these is going to be the square root of negative 4 minus negative 3 squared plus 2 minus negative 1 squared. Notice that this is equal to the square root of, so negative 4 minus negative 3 is going to be 1, or negative 1. And then 2 minus negative 1 is going to be 3, which is square root of 1 plus 9, which is the square root of 10. So square root of 10 is not a perfect square, so we can't factor out any perfect square. Square root of 10 is, the simplest form. We're going to get this number without a calculator. This is the exact value. There's no simplification that we can do. So the distance between A and B, or the length of segment AB, is going to be square root of 10. So now we're going to look at AC. So AC is the distance between points negative 4, 2 and 6, negative 2. So we're going to say D equals square root of negative 4 minus 6 squared plus 2 minus negative 2 squared, which is equal to the square root of, so negative 4 minus negative 6 is negative 10. And then 2 minus negative 2 is 4. Equals, so this would be the square root of 100 plus 16, which is the square root of 116. Notice that 116 is divisible by 4. I think it's 4 times 29. So since 4 is a perfect square, we can take it out. So this is equal to the square root of 4 times 29, which is equal to 2 times the square root of 29. So the distance between points A and C is going to be 2 times the square root of 29. And lastly, we're going to need to find the length of BC, which is the distance between negative 3, negative 1, and 6, negative 2. So negative 3, negative 1, and 6, negative 2. So we're just going to do the same thing. We're going to plug in the same formula. So this is going to be the square root of negative 3 minus 6 squared plus negative 1 minus negative 2 squared, which is equal to the square root of negative 9 squared. Notice you can flip them around to get a positive value, because negative 9 squared is the same thing as 9 squared. So negative 3 minus 6 squared is actually just the same thing as 6 minus negative 3 squared. But I'm just going to keep going with what I've already written. To that, you're going to add negative 1 minus negative 2 is positive 1. So plus 1 squared equals the square root of 81 plus 1, which is the square root of 82. So that's going to be the length of segment BC, or the distance between points B and C. So yeah, for the SHSAT, this is all you need to know about the coordinate plane. Of course, this is a really broad mathematical concept, and in general, representing numbers as visual things and visual representations of numbers are super useful. But for the SHSAT, this is all you have to know. If you have any questions, feel free to leave them in the comments as usual, and otherwise we'll see you guys next week.